Hello, and welcome to Understanding and Specifying Outdoor Displays. Welcome to the first section of our presentation, where we're going to discuss LCD technologies and what makes an outdoor display different from an indoor LCD display.
Now, why outdoor LFD? Why is this such a big deal today? Well, I gotta tell you, we're getting more and more applications that use this type of display product. Why? Well, think about digital signage as a whole and how many more digital signage applications all of us are running across. About 68% of us see one or more digital signs today. Just walk through the convention center here and how many different digital signs will you run across? And we're getting more demand for things like outdoor menu boards, outdoor directory signage. Think about national parks, theme parks. So with all of this demand, the need for an outdoor LCD is quite apparent. And so we're seeing more and more companies like Samsung develop products to meet that need. And we've got a variety of different ones that we will talk about at the end of the presentation. So outdoor LCDs are a really rapidly growing segment, and they're a great differentiator because it's a great way to put a message in a location that you wouldn't typically find it. Just think about yourself as a consumer. If you're going through, say, a parking garage, and all of a sudden, instead of a static poster in a light box, you see a digital display that's actually showing you relevant content, oh, hey, neat. That's a different kind of message, right? So let's kind of explore the concept of outdoor LFD and what makes it different. Like I said, we're going to start with an understanding of LCD technology. So here we have the core technology of what makes an LCD work. Realistically, this is the world's most sophisticated light shutter. Yes, really, that's what an LCD fundamentally is. Okay, it's fancier than that, but that's what it really is. Now, in order to understand how indoor and outdoor LCDs work, we have to have a fundamental understanding of the operational principle behind LCD technology so that we can see those differences. So let's start with the basic way LCDs are built. And all LCDs, regardless of manufacturer, are built the same way. It doesn't matter whose, okay? So what you're basically going to do is take a couple pieces of glass. We'll start there, basic construction. And that glass is mechanically rubbed to create grooves. And then we inject a liquid crystal material between the pieces of glass that are mechanically rubbed. Now, this is the magic stuff that makes LCD technology possible, because there's a couple of different operational principles that make LCDs able to be built. First, we have a material that is crystalline but liquid at room temperature. Liquid crystals, that's the important part. And then we also have transparent material that can conduct electricity. That's the second principle. Third principle, the liquid crystal material can be manipulated and have its state changed based on electrical current. So those three principles allow us to build an LCD. So we take and create a sandwich out of those mechanically rubbed LCD glass layers and inject that liquid crystal material inside. Now, a lot of people think that LCDs are relatively new technology. I actually assure you they are not. Some of the original principles that LCD technology as we use it today were developed in the 1800s. In the 60s, developers at RCA actually found that research and started figuring out they can make LCD displays. They can make display technology. They didn't call it LCD back then, but they can make display technology based on that. So these little liquid crystals that are in between those glass layers are the magic that makes all this work. Liquid crystal material basically looks like little cigar-shaped molecules, and it naturally forms a helix, like you can see there, looking kind of like DNA. All right? And that twist is important because we work with polarized light. When we take an LCD, we've got a polarizer applied on top of the glass, and the polarizers are applied perpendicular to each other, which means if you just shine light at it, the polarizer on one side polarizes the light, and the polarizer on the other side blocks that light used polarized. Well, the truth is that when we take the liquid crystal material, polarized light follows the twist of liquid crystal. Yes, really, it actually follows the twist. And so what we do is we use electricity to cause that liquid crystal material to untwist to varying degrees, which will ultimately create a path for the light to follow. And the polarizers will either block the light or allow the light through based on the twist. Yes, that's really it. All this fancy technology, all this research, and it gets down to that simple principle. Now, how does all this relate to why outdoor LCDs are different? We understand how LCDs work. Well, isn't an LCD an LCD an LCD? Well, kind of, but not quite. Here's the thing. There's different properties of that liquid crystal depending on its temperature. And that's something we've discovered over many years of development, where early LCDs used to have problems with high heat. Okay? And I'm going to explain why. Now, this whole thing, this sandwich, manipulating light is basically a shutter, right? This is why the biggest challenge in an LCD display is creating black, because we're blocking light and it has to be absorbed at some point. And that's really our main challenge. And we've come huge ways. Anybody who's seen early LCDs versus what we're doing today, it's amazing to see the ridiculous levels of contrast we can produce. Okay? And then, of course, we've got factors in how we produce color. Each pixel is broken up into 3 subpixels, and we put a color filter over it. The LCD material itself has no color. It's all monochrome. So we actually color the light using those filters. And that's how we get that. And there's been different configurations over many years. Different manufacturers use different types of subpixel layout and that, but that's fundamentally how an LCD works for producing color. Actually, not unlike how we produce color in an LCD projector, for that matter. Now we get to the key part about why this matters for outdoor. We have to understand a little fundamental bits about the states of matter. We all know that matter can exist kind of in 3 states, right? Solid, liquid, and gas. We know that from just playing around with water. We've all experienced it. Liquid water, steam, and ice, right? Well, liquid crystal material follows the same types of principle, okay? And the reason this whole thing works is because we have a material that exists between a crystal and a liquid, and it's stable at room temperature. And that's what lets all that work. But there are 3 main states of matter. If we go from solid, liquid, or gas, we can actually kind of distill it down to a particular set of scientific terms. So we've got 3 states of matter here that we deal with. Isotropic, which means the molecules are moving randomly. Pneumatic, which means they're ordered but still fluid. And smectic, which means they've formed a solid crystalline structure. So you can actually see this tracks kind of like solid, liquid, and gas. Not quite. But this really shows us that one of the early names, by the way, for a lot of liquid crystal displays, you'd see TN, TFT, LCD. You remember that term? Twisted pneumatic thin film transistor. That pneumatic state where it's still fluid and the molecules can move, but they follow an orderly pattern, tells us that's why liquid crystal works the way it does. And it moves based on heat. So in order to build outdoor grade LCDs, we have to be able to deal with the concept of keeping the liquid crystal molecular structure, yes, I did just really say that, in its proper phase. And that's really what this all comes down to. And that's what's really critical about an outdoor LCD. This is why you can't take just a standard flat panel and stick it outdoors.